Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more, help us to share our video and also subscribe to our channel. If you have not subscribed, help us to subscribe on it. And if you want to make any help, any contribution, you can call us on this number 234 344 95990. Now you can make a contribution to us by calling. To reach us, calling. You can also WhatsApp us, and Telegram us. Anyhow, at this point, we need help. We are seeking for help. We need a bigger board, need a larger, better camera, and pay our tutor and buy more things on our studio here. We have over 170 videos on our platform. It means you can come to our platform and learn any topic of your choice without no problem. I'll be walking you through on the equation of tangent at x1, y1, which is x1 to ellipse. We are still on ellipse. Now it means I'm working on tangent and normal of ellipse. That's what I want to work on. Now when we talk about ellipse, I will try to do one or two things here from our normal elementary calculus. Now it means we have done earlier that a squared plus y squared all over b squared equals to y. Now if I differentiating implicitly. Now it means I'll be having 2x all over a 2x all over a squared plus 2y all over b squared dy the x equals to 0 is a constant. Now, since I have this way, I can say that 2y all over b squared dy dx equals to minus 2x all over a squared. Now, since I have it this way, my a squared all over dy equals to minus 2x all over a squared divided by, which is it will be times b squared all over 2y. This is advanced mathematics. I have to show some. I'm doing, I've done my own normal thing there. Now, I think at this point I can say that which it will be equals to b squared all over a squared dot x all over y. Now, at the point x1, y1, dy, the x will be equals to, which is, we know what is called gradient. The y dx will be equals to, it will be equals to y minus y1 all over x minus x1. We all know this thing from our coordinate geometry, which is, I've done that earlier, which is a gradient form at the point anyway. That is what we are trying. It means y minus y1 all over x minus x1 equals to b squared all over a squared dot x all over y. Now, I can now say with what I'm having here, a squared y bracket of y, y1 equals to b squared x bracket of x, x1. With what I'm having here, I can say that a squared y y squared y squared, which is this and this, minus a squared y1 equals to b squared, what am I saying? There is minus here. there's a minus there. It means since that is a minus, the story will change. If that is the case, the story will what? Will change. This one will be minus. It means I'll be having, if that is the case, here will be y1, the story will change, and a, that will be s squared, and this one will be minus x plus b squared x squared 1. Yeah. Am I doing the right thing? This time, this. Now, minus will be here. Since I have it that way, I can continue by having a squared y1 plus b squared x1 minus a squared y squared 1 minus b squared x squared 1 equals to 0. Now, as the points x1, y1 is on the ellipse, therefore x1 squared all over b squared plus y squared all over b squared equals to 1. It means I'll be having b squared s squared plus a squared y squared equals to ab squared. Call it equation not. Now, equation not. Now, since I have it this way from this equation. Now, okay, I can see that from equation not, which is a squared y1 plus b squared x1 minus bracket of a squared y squared 1 plus b squared s1 squared equals to 0, which I can say that now substitute a squared b squared into equation star, which I'll be having 4 for a squared y squared 1 b squared s squared 1. Okay, now I'll be having a squared y1 squared plus b squared x1 minus ab squared equals to 0. It means all what I have there equals to 0. Now, since I have it that way, I can now say that a squared y1 plus b squared x1 equals to b squared. Now, which I will have something very good. Okay. Now, since I have it this way, I can continue divide through by a squared, because we are working towards ellipse, a squared b squared. Now, which I'll be having it will be having okay, when we divide both sides by that, I'll be having y1 all over b squared plus x1 all over a squared equals to 1. Now that is our equation. That is tangent. This is the tangent. This tangent of ellipse. This is tangent of tangent. Please don't forget that. It's very, very important. That's what we are going to be using as far as this video is concerned. Now, please at S1, please at that is very important. Now, with what is on ground, let me try to show one or two examples. Illustrate. Okay, let me try to work on number before we talk about example. Now, I'm now on number in the ellipse. Now, if I should talk about number, here will be number. Now, here will be number. Now, if I'm to talk about number, I'll be having x squared all over y a squared plus y squared all over b squared equals to. Now, since I have it this way, dy dx will be equals to b squared minus a squared x over y. I'll explain that earlier. Now, at x comma y, dy dx will be equals to minus b squared all over a squared x. This is 1. Now, let m be the what? Gradient of the normal. It means my m will be equals to minus 1 x1 all over y1 minus 1 s1 all over, okay, minus 1 dy dx. Okay, I can now say that which is it will now be equals to, which also implies a squared b squared plus y1 all over x1. Now, the equation of the normal becomes y minus y1 all over x minus x1 equals to a squared all over b squared dot s1 all over x. Now, which I can now do one or two multiplication. B squared x1 bracket of y y1 equals to a squared y1 all over s minus. Now, with this, I will have b squared x1 y minus b squared x1 y1 a squared y1 x minus a squared y x1. Now, since I have this type of things, open bracket, I can now say that b squared x1 y minus a squared x a squared x y1 equals to b squared x y1 minus a squared x y1. Now, which I'll be having a squared xy minus b squared x1y equals to a squared x1 y1 minus b squared x1 y, which I can now say that because I'm having here, I can now say that a y b squared x equals to a squared b squared and x1 y1, which I can now say that that is the equation now to the normal. That is the equation we are talking about. That is normal equation. Normal equation. Now, that is normal equation. With this, let me try to give one or two examples that will help us to understand this very well. Now, I have this type of question. Find the equation of the targent and normal to the ellipse 4x squared 25y squared equals to 100 at the minus 3, 8 all over 5. Now, what I need to do is that I want to solve this particular problem, solution. Now, once I have it this way, I can say that 4x squared equals 25y squared equals to 100. Now, I can say that x squared all over 25 plus y squared all over 4 equals to 1. It means my a equals to 5, b equals to 2. Now, it means I can now say that equation of tangent at x1, y1 is x1 divided by a squared plus y1 divided by b squared equals to 1. Now, at minus 3, 8 all over 5. 8 divided by, not 8 divided by 5. It means I'll be having x bracket of minus 3 all over 5 squared plus y 8 all over 2 divided by 2 squared equals to 1. Now, since I have it that way, I think I'll be having 3x minus divided by 25 plus 8y divided by 20. Yes. Divided by 20 y equals to 1. That is what we are in need of. I can now do one or two things, which is I'll be having minus 12x plus 4y equals to 100, which I'll be saying 10y minus 3x minus 25 equals to 100. That is the equation that I'm looking for. Now, if it is normal, I don't need to stress myself. It means this is the equation of normal. At a point, it means I would have what is my gain? 25x bracket of 8 all over 5 minus, I'm now on normal. B, what is my b? My b is 4. Yes, my b is 4 bracket of x1, y1, and continue, which is x. What is my x? My x is minus 3, which is going to be plus bracket of 3 and y equals to, what is my a? 25, which is going to be 25 plus 4. That will be 25 plus 4. 25 minus 4 bracket of minus 3 bracket of 8 over 5. And by so doing that, everything we need is already available, which I can say that here 1, here 5, 8 times that will be 40. And we have it 40x. This one will be 12y equals to 40. I'll be having this 21, 20 something, that'll be 24. That'll be 24. This one will be 24, 21. That'll be 24 multiplied by minus 20. Minus 24 multiplied by minus 21 divided by 5. Nothing can divide. I think I can multiply everything by 5. 40 times 5, 40, 40. That'll be 200. Times that'll be 60 equals to, which is going to be 5 minus 504. 504. Since I have it like that, I can now say that 200x plus 60y plus 504 equals to 0. And can I reduce? Yes, I can reduce everything by what? Now, by I think I can have 50x minus 5y plus 120 equals to 0. By so doing this is what? Equation of normal. This is normal equation. And this is tangent equation. That is all about that. And see how normal and Ellipse is being done. That is all about that. The next video will be on the hyperbolic. I think it's very simple also. Very simple. Very, very simple to understand. Don't forget to help us to share further. This is further solutions academy. Further solutions academy. Encourage us more to share and subscribe. Subscribe if you have not subscribed before. And for any help you want to contribute to this platform, we have over 170 videos presently. Over, more than that. Don't forget to share. And if you want to make any contribution, you want to buy a better camera, you want to buy a larger board, and also pay some tutors for some topics from subjects, don't forget 234 344 9597. You can call us on this number. You can call us, and you can WhatsApp, and also you can Telegram. Also is now. Okay. Thanks for watching. Thanks so much. Thanks so much.